Section 10, question 1. Find the equation of the tangent to the curve with equation y equals 3 over x at the point where x equals 1. Remember, a tangent is a straight line, so to find the equation of a straight line, we'd point gradient. Gradient in this scenario is gotten by differentiation. So I'm going to first of all prepare to differentiate, and 3 over x is going to be 3x to the minus 1. Then I'll differentiate, and that gives me minus 3x to the minus 2. Bring the minus 2 back down, and that's minus 3 over x squared. I'm looking at the gradient of the curve when x is equal to 1. So I'm going to sub in x equals 1. And that will give me minus 3 over 1 squared, and that's minus 3. So the gradient is minus 3. Also need to find the point. So I've got an x coordinate, which is 1. To get the y coordinate, just sub x equals 1 back into y. So that's y equals 3 over 1, and that's 3. So I've got a point 1, 3, and the gradient, which is minus 3. And I put that into y minus b equals in bracket x minus a. So that's y minus 3 equals minus 3 bracket x minus 1. Y minus 3 is equal to minus 3x plus 3. I'm going to bring minus 3 over, and that will be y equals minus 3x plus 6, and that is the final answer to the question. Higher section 10, question 2. Which of the following is true for the function g, where g dashed x equals x squared plus 2x plus 1? Option A, g is never increasing. Option B, g is decreasing and then increasing. Option C, g is increasing then decreasing. And option D, g is never decreasing. Well, the function's already been differentiated, so that means the function is representing the gradient. So the gradient's given by x squared plus 2x plus 1. So what I can do with that is to factorise it, and if I do so, I'll get x plus 1 bracket x plus 1. That can now be written as x plus 1 all squared. Now that's a measure of the gradient. So the gradient is x plus 1 all squared. Now something squared can never be negative. The least possible value it can take is 0. So for that, what we'd say is that x plus 1 all squared is greater than or equal to 0 for all values of x. Therefore, what we can say is that the function is definitely never decreasing. The gradient is never negative, it's always greater than or equal to 0, therefore it's option D. Section 10, question 3. Part A, write x squared minus 10x plus 27 in the form x plus b all squared plus c. That's just a straightforward complete the square question. So that's x minus 5 all squared. 25 will come out of that, so I need to get rid of the 25 and add on 27. And that's x minus 5 all squared plus 2. Part B then says, hence show that the function g of x equals 1/3 x cubed minus 5x squared plus 27x minus 2 is always increasing. Right, hence means it's going to be somehow related to part A. Increasing is asking me to look at the gradient of the function. If it's asking me to look at the gradient of the function, then it's telling me to differentiate. So that's g dashed x equals, so 1/3 x cubed, bring the power down, multiply, so 3 times 1/3 is 1 off the power, and that's x squared. Minus 5x squared becomes minus 10x, and plus 27x becomes 27. The constant minus 2 disappears. We can see, as I expected would be the case, that that's the same function as that. We've already completed the square with that function, x squared minus 10x plus 27. So the hence bit is really telling me to write g dashed x, x squared minus 10x plus 27, as x minus 5x squared plus 2, which I've already worked out. That's what it is. Now remember that g dashed x is a measure of the gradient. It's a differentiated function, so this represents gradient. Now if I look at this particular portion of the answer for the gradient, x minus 5 all squared, something squared can never take a value which is negative. Therefore, the least possible value for the squared bracket is 0. Now, if that's true of that portion of the gradient, then we can see that the full gradient is given by the squared bracket plus 2. So if the lowest possible value that the squared bracket can take is 0, if we add on 2, that means the lowest possible value the function can take is 2. So what we can say there is x minus 5 all squared plus 2 is greater than or equal to 2 for all values of x. So what we're saying at that point really is that x minus 5 all squared plus 2 is a measure of the gradient. So what we're really saying is the gradient is greater than or equal to 2 for all values of x. Therefore, function is always increasing.